Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're going to talk about V2 rocket engine. Why? Because I'm talking about rocket engine and we have to talk about Daddy. So this is the history of this. Basically, German built a stuff. Basically, when they were doing war, they had a secret organization inside their secret organization that was building multiple projects. This was second number project. That's why it has V2. It does not mean there was a V1 rocket. It was just like V1 different project. This was V2 project. I'm not gonna try to pronunciate the German saying of that. However, the meaning translates to vengeance weapon. So vengeance weapon 2. That's why it has V2 rating. And this was puppy in service from 1944 to 1952. Now be mindful, this had surprisingly shocking psychological warfare. Like as a weapon, in terms of modern context, it's like, dude, this is useless. But in terms of psychological warfare, this was like god tier weapon. Because when this was deployed, think of it this way, there was no air defense system that could shoot it down. No aircraft could even bother to see it, let alone actually intercept this. And this was supersonic, so you could not hear it until it was too late. So that was very short. And because the guidance system was like basically sloppy at best, so it was like go in that direction at best and run out of fuel and just fall. So that's also created a paradoxical effect where they were like, dude, you do not know what will be boomed. They because of course German would want to like, okay, this is the strategic places, this is the important places they want to go. Soldiers would like, okay, let's concentrate on this area, let's defend this area. But missiles had sloppy guidance, so it could literally go, they will launch it, hey, go there, boom that. It's like, nope, anywhere else. So that was very shocking. And like one time it actually landed literally in on top of a basically vehicle in a crossroad. Like it was so shocking in terms of psychological warfare. And this also reached space. This became the first artificial object to reach space, and this puppy achieved that in 20 June 1944. Let that sink in. 1944. This was basically Mark 1 variant of Jeff Bezos' rocket, so to say. And height achieved was 176 kilometer. That is significant. And even if carbon line was in miles, as in 109 miles, it would have cleared. So it was wow ahead of its time, so to say. And it was brainchild of Wernher von Braun. That's why this individual has such a high prestigious name, so to say. Like, of course, he single-handedly did not build this puppy, but in terms of like who had this core idea, who started to align a team and all that, like German people did figure it out. This dude is smart. That was the one good thing they figured out. This dude is smart, gave him resources, and the dude kind of lost any what you call morality grips. So dude just went to work, no matter the cost. So this is the history of this vengeance weapon. So how did this work? Well, this puppy was open cycle. The reason why I'm calling it open cycle is a bit different. It was semi-cryogenic. They figured out liquid oxygen. Now, it had to basically four things that it had to carry. So it had 3.8 tons of fuel. That fuel was 75% ethanol and 25% water. Now you're like, wait a minute, why the heck you have diluted fuel? Well, back in those days and their lack of understanding, be mindful, this is Mark 1 project. So the metals were not able to handle 100% ethanol. Like it was just not stable enough. Even if metal could handle it, turbochargers will go boom. If this will happen, this injectors will melt. Some things were always like, it was just not stable enough. And when you are building a weapons grade project, it had to be like, you build it, you launch it. You do not have time to fine tune it and all that. So this was the compromise that gave them the most oomph with most reliability. And yes, they were worried about reliability of the first rockets. And it had almost 5 tons of basically liquid oxygen, around 4,910 kilograms of it, or 10,000 pounds of it. So they had liquid oxygen. That's why semi-cryogenic. And it had total mass of around 12.5 tons. Now, this is how you should be able to understand like how behind it was compared to modern weapons. Modern weapons, like even if you take a ICBM device, the fuel to basically whole mass ratio is surprisingly 80 to 90%. Like 80 to 90% of whole rocket is just fuel or propellant. Here it was that ratio was not achieved yet. It had 1 ton of boom powder. This black puppy, that's boom powder. This was supposed to do the main boom thing. However, calculation shows that it was kind of useless. They could have just put concrete here. Because of the velocity, it would do the same amount of damage. Again, I do not know how accurate that is, but this may add extra firepower. You don't know. Range was 320 kilometer, altitude 88 kilometer, and this puppy achieved velocity, maximum velocity ever recorded was 5,760 kilometer per hour. Yeah, this puppy almost touching hypersonic, as in Mach 4.6. Hypersonic starts at Mach 5 above. So that's why I find people who are talking about hypersonics odd. It's like, dude, you do know we have ICBMs. You do know that puppy travels at almost orbital velocity. That's exponentially higher than hypersonics. And this was the negative photograph they took from the space. This is the first photograph of space, so to say. So this was V2. Be mindful, the before the payload there was the instrument bay. That instrument bay was made out of plywood. I'm not even joking, it was actually plywood. So what about the engine? How the heck this puppy worked? Now this is the shocking part. It was surprisingly ahead of its time and surprisingly behind of its time, all at the same time. So single turbo shaft pump. This was very clever. Simplify everything, have less parts. Awesome. Single turbo shaft, one side taking care of basically fuel, another side taking care of oxidizer. We're done. We're good. Now this puppy had RPM limit of 5,000, and if it crossed that RPM, there was a locking system that will basically disable the supply, and boom, the rocket will go boom. The idea with that is, hopefully at launch there was a serious probability that it could over RPM. So at launch they had the probability of saving the rocket, so they had that system. It's like, if you cross 5,000 RPM at spool up time, just stop. So the grand total horsepower was around 600 horsepower. Not too much compared to modern context, not too much, especially for primary propellant pumps. It's not that much. Now here's the deal. Where the heck you get 600 horsepower? You get it from NaMnO4, which making love to H2O2. Whenever you hear about people talking about like peroxide, it had a two-part system on that. So it had NaMnO4, that was this canister, and it had hydrogen peroxide. This was this big puppy canister. It's big, so people talk about it, but be mindful, this alone will not do enough oomph where it can actually drive the turbine. So it needed some extra love, some extra decompositing acid, so to say. So this was there, and both of them required pressurization. So they pressurized using scuba tanks, a bit, not scuba tanks, but they were high pressure air pressure tanks. That's how it got that. And the steam that it was generated, it first went to the turbine. Turbine dropped the pressure, of course. You send GG amounts of pressure, GG amounts of temperature. Outside of a turbine, you're gonna get a very serious amount of basically temperature, but not the same amount of pressure. Pressure would have been gone to zero. So they got this. This was like literally very clever design. In the center, so they got the basically pressure part taken care of. After that, that heat that it had, the steam was heat. Before it was vented out, it had a basically similar tube structure like this, where it preheated basically liquid oxygen. Now, like, wait a minute, why? Well, there was a line extracted from basically the liquid propellant part, and that was to basically boil it off and pressurize the oxygen tank. Be mindful, for ethanol side of thing, they had air canisters that's gonna pressurize the fuel part. Okay, awesome. But liquid oxygen is so cold, if they use that pressurized canister, it will just, like, condense, so to say, condense the air. So it was not viable enough, and they could not have other things or too much of this or that at that point in time. So they were like, okay, just boil off little bit of oxygen, put it there, because the tanks were surprisingly thin. Like, tanks were surprising. So if it was going, and if you are like draining the fuel, there would be a time where atmospheric pressure will collapse it. So for that reason, they needed something to fill up the void space. Fuel was taken care of by air pressures, but this puppy needed oxygen to counteract that system. So it had a boil off cycle. So this is how the engine works. So it had a two-part component that created very high pressure, very high temperature steam. That steam, that basically propellant mix was taken care of by high pressure. Then the steam spun up the turbine. Turbine did the main system, and the exhaust was driven outboard. So between the four fins, you will, between two fins, you will notice there are small vents. That vent is for the output of basically peroxide and all that. Then we come to the combustion chamber part. Now, combustion chamber, it was very early design. Be mindful, this is the inherently first design itself. So it had basically burner cups, and they were rudimentary swirl injectors, so to say. So, and everything about this was designed in such a way that it can be mass produced. It was a weapons project, not a prestige project. So everything was like, can we mass produce it? So they were like, no, we need very precise holes. So it's like, we could not cast it or like design it in such a way. So they are like, okay, we're gonna make the stuff, we're gonna have coarse thread there, and we're gonna thread on the small nozzle holes that are very precise, and that will give us the swirl injector that we need. Now, of course, this is Mark 1 variant of it, so do not expect to be like modern swirl injector. It was like good enough, it did work. So it had 18 burners of those swirl injectors, so that cups that you see, that is inside of this cup, there are 18 of that puppy, and it had regenerative cooling back then. Yes, it has, like, if you look at the cut section, there is like two walls. Between these two walls, you had basically the fuel going there. This red line is the fuel line. That fuel line used to go there. That was the first line of cooling. That was the main reason why this did not melt. Then, to improve the probability of survival, it had a small lines that you see, the smaller red lines, the loop lines. These lines injected what we call film cooling, meaning there were tiny holes around the chamber, inside the chamber. So those chambers will leak, not even leak, so to say, like they will put a little amount of fuel there. So what will happen, the fuel will vaporize. So it will create a basically steam curtain that is, it's not, yeah, it had ethanol and water there, so some amount of steam curtain. So that curtain will create a film. That film will protect the basically absolute hot gases will not be able to make contact with basically the main chamber wall, and that's how they're gonna protect. So it's had film cooling and regenerative cooling, and this was Mark 1 product. So surprisingly far out in terms of how the heck you're gonna make sure this puppy remains cool. Surprisingly far ahead. So small hole, this was there, and it was made in parts. Everything was designed for mass production. That's why it does not have the same ecosystem that you see with other rockets. This was like, okay, how quickly we can stamp these puppies out. The injectors were made in lathe, so they were keep producing it, hundreds of it. Other mold parts were made by other things. Everything was like, get it out of the door as quickly as possible. Now, did they got everything right from a Mark 1 point of view? Except one thing, and they knew it. They knew it from day one that they messed up this part, is the oxygen manifold. So cryogenic oxygen, because again, it's a cryogenic and it's gonna making love to something that is super hot, the pipes will expand, and they could not come up with a simple design. Of course, this is Mark 1 design, but even they knew it. Like this, I think we messed up. It's sometimes it does happen when engineers design something, they're like, okay, did it, but the technician who have to install it, they were like, you want to do what? Okay, very precise torque, very precisely way of doing it. What's it? 2 joints of like doable, 4 joints of that doable. Having 18 joints by 2 on the 2 places, yeah, that's not happening. This was the sore spot for basically majority of rocket failure. This joints were never done properly because again, so many joints, all you have to do is mess up one, either on the top part or the lower part. You mess up that, it will come loose, oxygen will flow, and be mindful, this chamber is super hot at that point in time. Yeah, boom, fire. So combustion, that part was very messy, and they knew it. They knew it. There are some design documentation. Of course, they did not have time to refine it. Otherwise, they would have done that. But and be mindful, when those German engineers went to basically America, they built the Mark II variant of it. That was the first thing they fixed. Everything else was surprisingly Control C, Control V. This was like, nope, yeet that puppy out of there. So this is the combustion chamber part of it. So what was the legacy of this system? Well, it gave humanity 2 tools. First tool is wings for space. We can go to space now. Then it gave us a boom tool for our own oblivion. So we can basically send ourselves to poof if we want to. So same tool, 2 way of utilizing it. So that's a very big thing. Now be mindful, USA, there was an actual time where they were actually afraid of Soviet Union, like really, really scared of it. So they realized that Germany is going poof. And they're like, okay, we really worked our ass off to make them go poof. So what is the resource we can get out of it? Again, money gone, loss of life gone. So what can we do to recoup it? They're like, what is the most expensive thing in this world? Brain power. So they created an operation known as Operation Paperclip to literally drain as much brain as they can drain out of Germany. So those scientists, engineers, technicians, doctors, all of those puppy do not end up in Soviet Union. That's how they scared they were. And again, public was like outraged. It's like, dude, you are letting, whose name I cannot say, the shall not be named, those people in American soil with full, like, you're a scientist here. It's not like, oh no, you have to work under like a lock and key. No. It's like, you are fully, it's like, people were outraged, but America was so scared of Soviet Union. They were like, no, we have to do it. It was considered as like, lesser of 2 evils, so to say. So they worked their ass off. And be mindful, he did not came alone. Like, there was at least 100 rocket scientists itself, and grand total, some mathematics suggests there were more than 1,000 people. More than 1,000 top minds, so to say, basically cream of the cream of the cream were taken literally from Germany. And again, it did bear fruit. Dude literally went from V2 to Saturn V. This happened inside his lifetime. He went from V2, that was like, can you please go in that direction, to, think about it, like how much innovation that happened. It's like, can you go into that direction, to, no, we are going to the goddamn moon. Think about it, like how our navigation went from let's hope to, no, we got it. Like, to give you an example, how early navigation systems were, like how early V2 was, is that they had a gyroscope. Awesome. Gyroscope had AC motor. But again, AC motor allows you to make it brushless, so everything was fine. But here's the deal. How the heck you give AC power into a rocket? You don't. You just have battery that creates DC. So somebody came up with the idea of mechanical converter. So DC power came into a DC motor that spun up a small AC generator. That AC generator was, spinning up the main puppy, so to say, main gyroscopes and all that. From that to Saturn V. I thought Saturn V's instrument ring was like, very crude and all that. I looked at instrument ring of basically V2 and I'm like, Saturn V is masterpiece. So that's the whole point. It is a very big, important step. And I was shocked, like when I looked into it, remove the peroxide part, remove the part that it needed basically a third ecosystem to drive it. How advanced they were. They figured out regenerative cooling, they figured out how to manufacture it, they figured out everything. Damn. And this was like before 1950? Are you kidding me? So there is a significant legacy. Whether you like it or not, that's a different thing, but it is significant. And it did give us like wings and booms. So that's up to us. What do we do? Either we go boom or we go wings. That's up to us. So this was my presentation on basically V2 rocket. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.